Yes, welcome back. So actually, now I would like to discuss about the operators. In previous class also I started like that. Now operators, what are the different operators readily available in the language in order to perform different operations. First of all, let us see what are the different operators here. Those are the logical operators, relational operators, shift operators, adding operators, multiplying operators, and miscellaneous operators. Like that, all the operators are classified in the language: logical operators, relational operators, shift operators, adding, multiplying, and miscellaneous operators. Okay, so this is the classification of operators. Then coming to first of all logical operators. What for these logical operators and how many logical operators are available, uh, and how the operator can be used, that we will see. That is, logical operator is in order to do the logical operations like logical AND operation, logical OR operation, logical NAND operation, okay, logical NOR operation, logical XOR. For that one, the logical operators are used on the binary data. Okay, so what are the different logical operators are available in the VHDL language means those are 6 logical operators are available. And actually in switching theory and logic design we have seen 7 logic gates including X and OR, but the available operators are only 6 except X and OR, except X and OR. Okay, so AND, OR, NAND, NOR, XOR, NOT. Okay. So now also see the example for usage of logical AND operation. So already in the half adder programming case or full adder programming case we have seen the use of two operators AND or AND operator and also OR operator. Okay, of course XOR also we have seen. Okay, now say here one example is sum less than equal a and b, that is sum is a signal object. So assignment symbol is less than equal. Okay, and now the right side expression is a logical AND operation on the numbers a and b. So a is a binary number, b also a binary number. On these binary numbers the logical operation here is AND. Okay, so like that you can use, the result will be loaded in the sum object. Similarly for carry, so for carry expression is a XOR b. Okay, actually sum is a XOR b, carry is a and b. Of course this is one example, that's all. Okay, so it performs XOR operation on binary numbers a and b and the result will be loaded into the object carry. Okay, so like that the other operators also we can use, so just whatever the logic gate and OR, NAND, NOR, XOR can perform, the same thing you can observe here, okay, by using these operators. And coming to another type of operators are relational operators. Okay, so what for relational operators? The relational operators are used to compare two different numbers, whether they are equal or not, greater than, lesser than, like that. Okay, so how many relational operators are available here? Here also 6 relational operators are available. See here, they are represented through symbols. Equal, first one is equal, then not equal, less than equal, greater than equal. Okay, so like that, so 6 relational operators are used in order to compare the binary numbers. Okay, so here is one example using if statement. If statement also we already studied in the first unit itself, in the behavioral architecture representation. Okay, so if is a sequentially executed statement. Its action is, if condition is satisfied, it executes a statement. If it is fails, it execute another statement. It execute the another statements. These two are separated by usually the word else. Okay. So if you observe here, if A equal to B, if A equal to B, then A equal B. If this comparison is satisfied, if this comparison is true, okay, then it executes Z equal to 1. That means it assigns a logical 1 to Z, a logical 1 or a binary 1 to signal Z. Okay. Else means if the else means A not equal to B. Else means A not equal to B. That is, the condition is false. The condition is false. The execution pointer goes to the else part and it executes Z equal to 0. That means assigns a binary 0 value to Z. Okay, then end if. So like that, with this condition, okay, in the condition the relational operators are used, okay, to compare the binary numbers A and B. The relational operators are used. Okay, then go to another one is shift operators. Shift operators, okay, usually in binary operations we are going to shift the bits from left to right or right to left, or sometimes we are rotating the given binary number or circulating the digits in the binary number, like that. So to do those actions or those functions, the shift operators, some shift operators are available in the language. They also 6 again named as SLL. SLL, that means shift left logic. SRL, shift right logic. SLA, shift left arithmetic. SRA, shift right arithmetic. ROL, rotate left. ROR, rotate right. Okay, so like that 6 shift operators are available in the language. So let us see the function of each and every one on binary data. Suppose if you take the example like this, the given binary number is 8-bit binary number 10001010. SLL by 2, shift left logic by 2. So what does it mean? The expected result is shifted 2 bits towards to the left side, That means the MSB position bits, in the original data, the MSB position 2 bits, that is 10 will be erased, and there are 2 vacant positions in the LSB position. 2 vacant positions in the LSB, they may be filled with the logical 0. Okay. So if you, then the expected result is 0 0 1 0 1 0 0 0. Okay. So see here, this is the result we may get with this shift operation. Okay. Following, during shift left by 2 means 2 bits shifted towards left hand side direction, and in this case 2 LSB position will become vacant. Those are filled with the binary 0, okay, or logic 0 value. Next, with another example, that is another example shows the usage of shift left arithmetic by 2. Shift left arithmetic by 2. So here also the data will be shifted towards the left hand side direction by 2 positions, and 2 LSB position will be vacant, but they are filled with the whatever the LSB bit is there, with that one those are filled. So in this case the LSB bit in the original case is 0, so that the zeros will be occupied in the vacant positions. Okay. Similarly, next operator is shift right logic. Shift right logic by 2. Shift right logic by 2. That means the data, the given binary data is moved towards right hand side direction by 2 positions. In this case, what will happen? The MSB 2 positions will be vacant. The MSB 2 positions will be vacant initially, but they are filled with the binary 0. But whereas in arithmetic case, what happens? Same thing will happen. the data will be shifted towards right side, but the MSB position, the MSB2 vacant positions filled by MSB bit of the original data, MSB bit of the original data. Okay, so here what is the MSB bit of original data? 1. So that's why in the result the two MSB positions filled with this MSB bit of original data, that is 1 1. So this is the expected results on applying shift right arithmetic. Shift right arithmetic, that is the difference between logic and arithmetic. Logic and arithmetic. In logic case, whatever the direction the data will be moved, the vacant places filled with 0 only, filled with 0. But in arithmetic case, the vacant position filled with the in the left hand side movement case, in the left hand side movement case, the vacant places filled with the LSB position of original data, whereas in the right hand side movement case, the vacant places filled with the MSB position bit of the original data. Okay, so like that you can see the difference between logic and arithmetic in right shifting and left shifting cases. Now see another two operators uses, that is rotate right and rotate left. First of all, rotate right here shown on the same data, rotate right by 2. Rotate right by 2 on this binary means here also the original data will be shifted by 2 bits in the right hand side direction, by 2 positions in the right hand side direction. But now what are the new bits in the MSB2 positions means the LSB2 bits of the original, the LSB2 bits of the original, since the data is rotated, the data is rotated. So when the data is moved towards right hand side direction, MSB position will be vacant, they may be filled with the LSB positions of original data or LSB bits of original data. Clear? Similarly, in the rotate left case also, the data is moved towards left hand side direction, towards left hand side direction with how many positions, since here represented by 2, so 2 bits only will be shifted towards the left hand side direction, and the vacant places in the LSB filled with the MSB bits of the original data. Okay, the MSB bits of the original data. So like that the shift operators uses you can observe, okay, on the binary data. Okay, so now I am going to stop this session. In the next session I would like to discuss the other operators uses, right? Thank you.